Courses in the cement industry. Present to you. In this course, I present to you, the most important maintenance for LOESCHE, raw material mill. Part 1. Table of content. Part 1. 1. Main assembly groups. 2. Maintenance. This section contains 1. Mill stand. 2. Mill body including lining. 3. Table. 4. Auxiliary parts for table. 5. Rocker arm. 6. Swinging out rollers. 7. Grinding parts and auxiliary parts for roller. 8. Roller. Part 2. 9. Lever sealing. 10. Spring assembly. 11. Cabinets. 12. Nitrogen accumulators. 13. Ring pipeline. 14. Filling and bleeding. 15. Mill drive. 16. Classifier. 17. Classifier lining. 18. Classifier drive. 19. Star feeder. 20. Water injection. 1. Main assembly groups. This raw material mill contains 1. Star feeder. 2. Rocker arm. 3. Swinging out cylinder. 4. Mill stand. 5. Classifier. 6. Mill body. 7. Roller. 8. Table. 9. Mill drive. 1. Main assembly groups. This raw material mill contains 1. Star feeder. 2. Rocker arm. 3. Swinging out cylinder. 4. Mill stand. 5. Classifier. 6. Mill body. 7. Roller. 8. Table. 9. Mill drive. Function 4, main assembly groups. 1. The mill is a negative pressure, air-swept machine for grinding and drying the feed. 2. The feed lies upon the table and is crushed by the rollers. 3. The vertical motions of the rollers, when they pass over the grinding bed, are absorbed under load by the connecting hydraulic system. 4. The material over which the rollers have passed is thrown by centrifugal force over the rim of the table to the louvre ring surrounding the table. A fluidized bed is produced, and the upward flow of hot gases carries the ground material to the classifier. Intimate contact with the hot gas causes the moisture contained in the ground material to evaporate spontaneously. 5. The finished product passes through the classifier, oversized fraction is returned by the classifier, via the internal tailings recycle to the table, for further size reduction. 6. LOESCHE roller grinding mills are started under no load conditions. The rollers are lifted by the hydraulic cylinder before the start and then lowered after starting. Motors with low starting torque are therefore used for the drive. No auxiliary drive is necessary. 7. Metal-to-metal contact between the grinding parts is avoided, by the use of buffers or proximity switches. 2. Maintenance. Mill stand. Visual check. In this point check. 1. Condition of bolts, of bearing caps. 2. Condition of weldings. In this point check. Oil accumulations, on concrete foundation. In this point check. Condition of anchor bolts. In this point check. Condition of gearbox, attachment bolts. All this point check. Interval, weekly. In this point check. Variant 1, super bolt system. In this point check. Variant 2, hydraulic tension system. Check torque of variant 1, or variant 2, yearly. Function 4, mill stand. 1. The mill stand serves as the base of the mill. 2. The mill stand supports the grinding mechanism and the power transmission components, together with the pedestals. Maintenance 4, mill stand. 1. Immediately after startup, tighten bolts on bearing caps. Repeat this operation after 8 operating hours, and finally secure heads, as indicated in the drawing. 2. Hexagonal nuts inside and outside the pedestal must be tightened, and after approximately 100 hours of mill operation, the nuts are to be welded in accordance with instructions given on the assembly drawing. 3. Hexagonal head bolts of the gearbox foot flange must be tightened and secured as indicated in the gearbox documentation. 4. Wedges, if fitted, must be inspected after approximately 24 hours of operation, and tightened if necessary. Wedges are then tack welded lightly. 5. Reject flaps are to be kept closed during the operation of the mill, in order to prevent access of secondary air into the mill. 6. Reject flaps are to be inspected for close contact with the exit chutes. Refitting must be carried out, if necessary, to assure proper seating. 7. Reject flap seals are to be inspected for wear and exchanged if necessary. Mill body include lining. Visual check. Lining plates inside mill body, and ring duct. Maintenance. 1. Replace worn lining plates. 2. Replace worn wear plates. The cast lining plates are interchangeable. Interval. 1. Check wear monthly. 2. Shift interval according to the specific wear behavior of the mill. Function for mill body. 1. The ribbed castings serve as autogenous liners. This expression is used because they are self-protecting. The ribs are inclined rectangularly to the upwards directed primary airflow. Thus grinded material fill the gaps between the ribs so that mainly dust slides over dust. 2. A part of the friction wear is converted into impact wear, which leads to less erosion. Maintenance for mill body. 1. Tighten nuts of the special taper bolts, following the sectional view. 2. When replacing liner plates, new bolts and sealing rings must be used. 3. Worn liners must be replaced only after the ribs are washed off and the basic material starts eroding. 4. Liners must not be replaced all at the same time. A partial replacement dependent on the wear condition is sufficient. 5. Sheet plates should be replaced before showing holes. Table. Visual check. Condition of 1. Dam ring. 2. Louvre and armor ring. 3. Clamping ring. 4. Scrapers. Maintenance. 1. Repair by fill-up welding and hard facing. 2. Replace worn parts. Interval. 1. Check wear monthly. 2. Shift interval, according to the specific. 3. Wear behavior of the mill. This video shows the components of the mill from the inside, including the table. Function for table. 1. The primary function of the table is to support the grinding bed and transmit the force generated by the rollers into the gearbox below. 2. It also transmits the torque of the gearbox into the grinding zone. 3. Together with the ring duct, the table creates a circular chamber, out of which the primary gas flows over the louvre ring into the grinding chamber. 4. Beside the rollers, the table is the second grinding tool of the mill. Maintenance for table. 1. Control grinding plates monthly. 2. The grinding plate is, because of its structure, very brittle. Cracked segments have to be exchanged, however, only if broken pieces find their way onto the grinding path and cause holes. Usually the cracked grinding plate segments wedge themselves so tightly together that they will not have to be exchanged before the normal wear period has expired. 3. The regular exchange of the grinding plate should be made at the latest, when the normal production rate cannot be maintained. If the wear is largely confined to the roller tires, then the grinding plate need not be changed. Auxiliary parts for table. 1. Table support, used when change gearbox. 2. Hydraulic jack. Use this auxiliary parts for table when maintenance work. Rocker arm. Visual check. 1. Bolts. 2. Grease pipeline connections. Maintenance. 1. Change wear rings of sealing air, assembly check bearing clearance. The gap is due to the installation, in the range of millimeter. 2. Change bearings. Interval. 1. Visual check weekly. 2. Maintenance. 3. Check bearings yearly. 4. Check sealing air gap in 6 months. 5. Shift interval according to the specific wear behavior of the mill. Function for rocker arm. 1. The rocker arm transmits the forces produced by the hydraulic double-acting cylinders onto the roller and the grinding bed. The hydraulic cylinders are linked at the jointed pin at the lower end of the rocker arm. 2. Hydraulic cylinder and rocker arm are arranged in such a way that the bearing reaction forces are always directed into the pedestal. By separation of the central rocker arm from the fork, the roller can be swung out, without having to divide fork and springing cylinder. 3. By means of a bore with inlet pipe, on the lever seal, air is delivered to a coaxial gap between the roller and the rocker arm. It prevents the ingress of dust into the cylinder bearings, sealing air system. 4. A geometrically adapted sealing box seals the rocker arm against the mill body. The rounded surfaces of the sealing box rotate concentrically about the rocker arm axle. Here are some pictures and videos showing you the rocker arm. Maintenance for rocker arm. 1. The clamping connection between the fork and the axle must be tight. Even a small amount of clearance will cause deformation of the bore in the fork, and could lead to eventual breakage of the fork. 2. The bolts of the axial thrust rings must be checked for tightness. The cap must be removed for this purpose. 3. All bearings are to be lubricated regularly. An interruption of the flow of lubricant will lead to seizure of the bearings. 4. Transparent hose, if exists, which leads from the sealing air chamber down underneath the master rocker arm axle, should be inspected to see if there is any oil present inside it. Should leakage oil be present here, then check the roller's slip ring seal. The striker plate on the lower end of the fork must be exchanged if it becomes deformed, through frequent contact with the buffer. Swinging out rollers. Lever and fork connection. Proper dismounting and mounting of taper pin and flanged sleeve connection of rocker arm fork connection. Dismounting procedure. 1. Install the swing out cylinder. 2. Remove cover disc and disc springs. 3. Remove taper pin and sleeve. 4. Remove connecting screw. 5. Remove flanged sleeve. Mounting procedure. Mount all parts in opposite direction. Prevent the taper pin and sleeve with anti-corrosive paste. Visual check. 1. Check completeness and function of all auxiliary parts in advanced storage. 2. Swinging out cylinder to be stored vertical. In this video, shows the process, how swinging out rollers. Function 4. Swinging out rollers. 1. The hydraulic swinging mechanism enables fast changing of the grinding parts in the LOESCHE mill. 2. With the help of a hydraulic cylinder, the roller is swung out of the upper housing, and the rocker arm is supported. 3. The mounting area above the table, given with swung out roller, facilitates the substitution of lining segments. Maintenance 4. Swinging out rollers. 1. Check pins and mounting brackets, before each swinging out, for possible damage and rust defects. 2. Hydraulic cylinder and piston rod, have to be protected against external damage. 3. Please store the high-pressure hoses in a safe place. When replacing them, hoses rated at a burst pressure of more than 200 bar must be used. 4. Store hydraulic cylinder vertically after use. The piston weight deforms, otherwise the piston rod seals durably, what leads to leakages. 5. Storage. In case of a longer storage time, change oil every 3 years. Grinding parts. Visual check. 1. Check wear of tires, with tire profile ruler. 2. Check wear of grinding plate. Maintenance. 1. Change grinding parts. 2. Welding of worn out sections of tires, grinding plate, and wear rings of dam ring. Interval. 1. Check wear monthly. 2. Shift interval according to the specific wear behavior of the mill. Maintenance 4. Grinding parts. Dismantling the roller. 1. For dismantling the roller, to extract it from the rocker arm, lifting eye nuts and or eye bolts are provided. 2. Swing out roller. 3. Bolt eye bolts to the hub cover. 4. Loosen and remove connecting bolts from axle. 5. Bolt ring to the claw ring. 6. Bolt pressing off cylinder to the ring. 7. With the help of the hand-operated pump of the table dismantling auxiliaries, push the roller axle out of the rocker arm. 8. Extract the roller from the rocker arm by means of a crane. Grinding parts and auxiliary parts for roller. Auxiliary parts for roller. Hydraulic jack. Eye bolt. Lifter. Maintenance 4. Grinding parts. Installation of roller. 1. In general, the assembly has to be executed in the reverse order. 2. The roller is tightened in the position which is indicated on the drawing roller. 3. If a temperature sensor exists, see operating instructions, roller temperature monitoring. We follow maintenance 4. Grinding parts. Change of roller tire. 1. To avoid the danger of accident. A. Check the condition of the lifter before usage. B. Pay attention to the maximum permissible load which the lifter may carry. C. The lifter may only be used for the transport of roller tires. Removal by force from the hub is not permitted. 2. Swing out roller and the rocker arm out of the mill. 3. Loose the nuts of the hammer bolts. 4. Remove the hammer bolts and the clamping ring of the roller. 5. Loose the roller tire from the roller hub. Therefore heat the roller tire all around evenly with a gentle flame. In this video, it shows how to change the process tire. Roller. Visual check. 1. Attachment bolts, of roller axle and tire. 2. Wear of guard. 3. Oil leakages. Maintenance. 1. Change wear rings, of sealing air assembly. 2. Change slip ring seal. 3. Change worn wear parts. 4. Clean air filter. 5. Take oil samples for analysis. Interval. 1. Visual check weekly. 2. Maintenance. 3. Oil analysis every 3,500 hours. 4. Change slip ring seal after 15,000 hours. 5. Shift interval according to the specific wear behavior of the mill. In this short video shows components slip ring seal and how change. Function 4. Roller. The rollers are tools carrying out comminution. Maintenance. 1. Ensure that the mill runs smoothly, make sure that the slides and flaps in the gas lines close tightly, check the height of the dam ring. 2. Keep the height of the dam ring relative to the grinding path exactly uniform around the complete perimeter. 3. Set the roller force correctly in accordance with the springs diagram. 4. Check the slip ring sealing regularly, see drawing slip ring sealing. Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.